right. So, hi, everybody. Welcome to the weekly meeting. I think we have one new face, maybe a couple new faces. So, good to meet you, Joel. Can you just, I missed before, can you say what organization you're with?
RTI.
Okay, great. Terrific. Well, great to have you. So, we wanted to have a focused discussion a little bit around SQL generation. So, we'll kick that off in a minute. I just wanted to go through any housekeeping and to-dos that are outstanding. So, I'm just taking a look at last time's meeting notes. So still in front of us is discussion items for the FHIR and OMOP. So we can talk about when we want to have that, but Craig will be leading that. I know there's been some chatter about OMOP and FHIR in their community. So let's stay abreast of that and the folks who are interested in it. I know Nikolai is also interested in that. So let's just keep that ball rolling. I will start up a Zulip thread or refresh it about the roadmap session. We wanted to talk a little bit broader and more longer term about the roadmap of where things might be heading with SQL and FHIR. So we'll schedule that for the next couple of weeks. Some more FHIR and OMOP stuff. Ryan and I had a to-do to propose the dev day sessions. We talked about that last time. I haven't done anything on that, and I don't think Ryan has either, but we'll get together and talk to Reen about the dev day sessions that we were thinking about, pretty similar to the sessions we had at the Connectathon. Nikolai working on documentation of test system that he showed last time, and then Ryan just making note of the spec changes on some of the issues that we discussed. So,
and I have two more guys committed.
Yep.
This is
okay.
Health Samurai. So now I think things will move faster because I was a bottleneck. Yeah.
Great to see more Health Samurai guys and more resources. So I feel like this is going to just keep growing. So get used to it. Good to meet you. That's all I had for housekeeping items. Does anybody have any housekeeping items for the group?
Yeah. So actually, I had submitted a talk. I just put together a submission yesterday, just basically doing an overview of the spec, a little bit similar to kind of what I did in the Connectathon, but in like a little more detail and more depth and more preparation than I did for a more general audience there. So yeah, so I just put that out there. Just wanted to mention that, but I think there's definitely room for additional talks as well. I think like practical usage, looking through the implementations, like a deeper dive into SQL generation, or there's a whole bunch of room for additional talks. So I kind of just scoped mine to basically, the content of what is on that what is included in the spec. So I figured that could be useful as a standalone one, but I'd be happy to refer to other talks for people going into other aspects of this effort.
Did you speak to Reen, or you just submitted a talk?
I just submitted it. I figure like things were coming up, so I mean, but we can follow up and adjust. I think we could be a little bit flexible at that point.
Oh, I see the deadline is tomorrow. I should get on that. Yes, thanks for the reminder. So, all right, that is a good.
I still think that it worth to talk to Reen. So, if it's night for you, I can try to reach him tomorrow somehow.
I mean, I've met him a couple times, but if anybody, wants to get connected with Reen, yeah, I'd love to see a spate of talks at Dev Days. I don't know how much he's been connected with this. We're connected a little bit with the FHIR League guys, but yeah, I would say Nikolai, reach out to Reen.
I will try to reach him tomorrow out if it's possible, and then write to the chat.
Okay, great. Yeah, I think there's a lot of momentum around this. Should be interesting. So I think Ryan doing what he did before, this kind of walk through, deeper dive through the spec with more time is definitely something we want to do. And then I would also love to have a practical type session as well, kind of like the demo sessions we had, but with more time, maybe about more practical use cases, getting into use cases a little bit. Those are the two sessions that I had. So maybe what I'll do is I'll put together a short proposal for that second practical demo use case session. Then people can talk about that. So I'll commit on that. And then Nikolai suggested a tutorial on, I think, your functional model, which I think would be super interesting, to be honest, like for myself in particular. So I think talk to Reen, maybe suggest that. So that would give us 3 different talks. Does anybody have an idea for another talk that you think we really should push for?
I think 3 is a lot, so we might want to focus our efforts, but it is worth thinking about the different formats they have. So, historically there have been these kinds of tutorials and then hands-on sessions. And I think we have enough pieces of automated testing and web runners and sort of components that people can just try out pretty easily, that it would be good fodder for a hands-on session. That might just be a rethinking of one of the existing sessions to sort of orient it more towards something that people can try out as the session unfolds.
Cool. Yeah.
And I've submitted the talks, and this is like SQL for the project, yes. And probably John, I don't know. So I think we have a lot of talks. That's why we should talk with Rin, because he probably is confused by many talks about SQL.
Probably. FHIR, can you remind me, you have your hand up, but can you also remind me what the agenda for your talk was that you submitted?
That's actually why I raised my hand. So we are submitting two, also a good point that Josh raised. So we are submitting one tutorial, and the tutorial is what I mentioned like last week briefly. It's basically a big part of it in SQL FHIR v2, such that we can make the data warehouse choice and implementation detail. So the idea is that, people can use our pipelines and then they choose, and I want Parquet, I want, use Spark, I don't want any of these, I want to use Postgres. And then you make that choice. And then there is a view layer on top of your choice where you build your downstream usage, like, dashboards or indicator reporting or whatever, against that, what is this, AI companion? So then you build the indicator library, the dashboard or whatever against the view layer. Then with these two in place, then you can just change the choice of the data warehouse with very minimal efforts. So that's basically that talk that we are submitting as a tutorial. And I'm just actually reviewing it today. Our product manager has written it, and he's waiting on me to finish the review and submit probably today or tomorrow. Then there is a let's build session on top of that. We basically, which is basically, people sit and then set up the pipeline, and then we introduce like an open source dashboarding tool. They create a very simple dashboard. And then it shows that, when the FHIR server data changes, the dashboard updates. That's one aspect of it. And the other one is that, whether your dashboard is against views on a Postgres or like a virtual view in Spark and Parquet, the dashboard would be the same.
Interesting. Okay, so we're adding a lot of sessions here. So maybe there's probably not room for too many more. But so, definitely.
And of course, not these necessarily don't go through. So some of them may not
be. And they shouldn't be exclusive. I mean, people shouldn't say, well, we shouldn't submit because, someone else is submitting. But I mean, I think that's a very interesting session. So, but probably we don't need too many more different kinds of sessions at this scale, I would say. Dan, you have your hand up?
Yeah. So to add to the confusion, I was talking to Ward about other sessions earlier today. And I asked him to reserve at least one session for kind of spec overview and one session as a hands-on for SQL FHIR and Arjun. I gave him your contact information and thought maybe you could coordinate for the group. So, because I think they're probably not going to want to schedule like 15 SQL FHIR sessions. So it probably makes sense to kind of consolidate and create maybe a couple-hour block and figure out like how we want to sequence that. And so maybe that's a spec overview and then a round table of implementations and then some hands-on time or something else. But I think probably at the dev days level, they'll want to kind of coordinate between all these sessions. So we have at least, it's not, of course, they haven't figured out the schedule yet, but he's aware that as a group, we're going to want several sessions and that we could, and Arjun, maybe you could be the point person for coordinating that for this.
Yeah, I'm happy to do so. So
and to Josh's comment, I'm not trying to cut anyone out. It's more just that I think there needs to be some coordination. So making sure that everybody who has something to present gets to present, but that we don't try to take over the entire Dev Days conference.
Exactly. Well, there are worse things, but yeah, exactly to Josh's comment. So anybody who I'll consolidate that, hand that over to you, Nikolai, if you're going to talk to I think Ryan, lead the spec session, and then have, sort of collect folks who want to be a part of the implementation roundtable and hands-on sessions and things like that. And then, add on to that. So happy to coordinate that for the group. So just please reach out to me and then, CC, I would say Dan and Nikolai, and Ryan potentially. So if we can do that, but I can be the point person there. All right. Anything else on the housekeeping item? Taking a look. Okay, so a little bit of advertisement. You might have seen in the chat. I put together a little glossary for SQL and FHIR, so please take a look at that. Give me any comments. So I'd love to get your feedback on that and then eventually integrate that with the spec. And then Josh, I think, do you want to give us a little bit of a walkthrough of what you've done previously? I know you did it before, but it was a couple of months ago.
Yeah, I'm happy to. I'll share my screen, and then I'm going to just put a link into the Zoom chat of what I'm sharing, which is just a markdown file in this repo. It's been a little while since I did this work. I actually was kind of shocked to see that it's been like 3 months, so 2 months. Forgot a little bit of how it worked. But I put together kind of an example to think about this problem of turning a view definition into essentially a SQL view or a set of SQL table expressions. So just for folks who are not totally plugged into this world, we have what we call our base layer. And Arjun, this is in your glossary. Will you remind me of the current name for this? The data layer, I think. So in a data layer, we just assume that somehow FHIR resources are in a database and queryable in a fairly raw way. And then view definitions are what are supposed to give us sort of nice rectangular take on top of those data. So what I'm showing you here is essentially some glue code that takes a view definition, our JSON structure for what we want to see, what columns we want to pull out from FHIR resources, and compile that into SQL that runs on top of that data layer. So just to be really concrete, I'm going to walk through one simple example. This is all a little bit kind of half-baked. It's not super well organized, but I just wanted to share it because A, it's what I have, and B, maybe it'll just generate some conversation. So let's assume we've got a database where every patient in this array of patients is represented in one row. In my example, it's going to be a SQLite database, and the patients are just going to be stuck inside of a string column called resource. But this is sort of the data layer. And my database right now consists of one patient, so there would be one row in my patients table with this resource sitting in it. It's just a FHIR patient, but I will draw your attention to the fact that this patient has a few different names because the name cardinality is an easy one to play with. And each name can have multiple given names. And the view that I'm going to be writing is going to be looking for patients that have a given name of A2, wherever that shows up in the list. So it's going to be finding a couple of these names. All right, so let's look at the view definition that I'm going to try to run on this patient. It's a pretty short one, but it's already enough to show some interesting sort of behaviors. So I'm doing a for each. So I'm looking for patients. And for every name that I find in a patient, I'm going to filter it down to just the names whose given names include A2. Now, so this should match the patient I showed earlier. And in particular, it'll match at least one of the names that we looked at of that patient. So just to say this concretely, it's going to match this name because it has a given of A2. And it's going to match this name because it has a given of A2. But it's not going to match this third name. So that's sort of what we're expecting to get out of the for each here. And then for every name like that, we're going to pull out a column also called A1. It's going to be a Boolean, and we're going to populate it with true if that same name also includes a given name of A1. So it's a totally contrived view definition, but the JavaScript that I have in this project basically takes this view definition, compiles it into kind of an intermediate representation by parsing these FHIR path expressions using FHIR path.js, and giving me a structure that I found a little bit easier to work with. But I'm not going to talk through this AST structure, except to show you that even for a pretty small view definition, the AST gets pretty involved. But I will show you the SQL that I then generate from this AST. I'm not going to run through it line by line, but I will show you sort of the intermediate parts that I build up as I'm evaluating the SQL expression, so you can at least get an idea of what's involved in it. But first of all, just to say, there's a whole screen full of SQL here for what was really a pretty short definition. There's definitely ways that this could be less involved, but this was sort of naively what came out. But let me give you an intuition for what all this SQL is actually doing. And the way that I'm going to do that is you'll notice this SQL consists of a bunch of table expressions. Basically, each of these lines that starts with patient underscore is its own table expression. And so I'm going to show you what the values of these intermediate tables are that I'm using to build up the final answer, the final view contents. You can see all of these things get built up, and then finally we just select star from the last one. So what are we actually building up here? The first thing we're doing is we're taking patients and exploding them into a list of names, because that was what our for each expression told us we needed to do. So source key here refers to the row in the database that this is derived from. So this is patient 1, so the source key is 1. And in fact, our database only has one patient, so the source key for all three of these is 1. And the key here refers to the specific path expression for which name we're looking at. So we have name 0, name 1, and name 2. Those are all names associated with that first patient. And then we're going to look inside of that set of names, and we're going to explode then each name into its given names. So our first name had 3 givens. So one of them was A1, another one was A2, another one is A3. So I explode each name, again doing this sort of for each, into its set of given names. And now we're going to start to see if these names are equal to what our FHIR path expression said they should be equal to, which is the constant A2. So I build up a table of A2. I'm going to check every single name against A2. So first I'll construct a table where A2 is in every single position. And then I'm going to compare that table to the actual values. And I'm going to get a 0 where they don't match and a 1 where they do match. And so this is sort of a table expression that's telling me which given names are equal to A2. And then I can start to summarize this table, grouping by the name they came from. So now I'm saying, okay, here's the second name included A2 somewhere, and the third name did not include A2 anywhere. So that table expression is starting to summarize or group those parts back where they came from. So this starts to give you an example of sort of how you can parse those FHIR path expressions into component parts that you build up one table expression at a time. And then you can start to iterate by those that I care about. I'm going to pull out the columns by doing a very similar thing. Now I'm looking at the list of given names for each column, and I'm going to see which ones are equal to A1. So again, same sort of trick here where I populate every single entry with A1, and then I run the comparison and see which ones are actually equal, and only this one is going to survive that comparison. And then finally, I'm able to get out the list of actual values for this column called name includes A1. And then finally, this gives me my result, which is patient 1 has this flag also called A1, which is true. And the next name has this flag, which is false. So this is just like one example. The code in this repository goes through the process of generating outputs like that markdown file that I just took you through. And it handles sort of a few things. It deals with some basic Boolean logic in FHIR path expressions by creating a table for each branch of the Boolean clause and then comparing those tables to create the result. It deals with exists. It deals with for each. And then very quickly, it sort of falls off in terms of what I've implemented. I just did sort of enough to try to give myself a flavor for what was involved. So I'm going to stop there. I expect that folks who are doing this for real probably have a lot more insight into how to make this kind of thing work and also perform well. But that's where I've got so far.
Thanks for that, Josh. Yeah, super interesting. Yeah, just open up to the group for questions. Bashir, you have your hand up?
Yeah, thanks, Josh. This was actually really cool. So to make sure that I understand, this example, so you basically expand, open up, and then it's become flat, and then you do a group by basically to group the resources that are from the same resource, right?
That's right. And I have a different table expression for every point of that syntax tree that I need to evaluate. So sometimes they expand if I'm doing a for each, and then they collapse if I'm doing something like an exists, or if I'm popping back from a nested select into the parent.
Yeah. So the thing that I was wondering, I don't have too much experience doing this view definition to SQL, a little bit on Spark with someone who actually was working with me. But so, I mean, from a performance perspective, how much do you think this is easy to do? Because the reason I'm asking is this because let's say you have millions of resources, right? And then the logic of the view, applying view definition, it is nice that, we have limited to that just one resource. So just having this one resource, you can get anything. I mean, you can apply the view definition to it and then get the rows. But many of the SQL-based approaches usually end up exactly similar to the pattern that you have, usually end up in requiring like table-wide group by. And those table-wide group bys can become very expensive because that's now a function of number of resources that you have.
Yep.
And so I don't know if you have done any kind of performance analysis on it.
No, I've never run it on more than one page or more than two patients. I was really just trying to get a feel for a path to generating SQL. But as you said, the locality of the data that you need to be able to group matters a lot. And I could imagine there are various partitioning schemes that would make a big difference in real life.
Yeah, I mean, just as another data point, I mean, that my colleague who was working with me on that Spark SQL. And Ryan can also add a lot more for BigQuery. But I remember that he went through a lot of pain because I kept asking him this question that, no, because we can do the whole thing without a group by, should write the SQL such that it doesn't need the group by. And he managed to do that, which was very nice. But I know that it was very painful to actually be able to do that.
I'd be very interested to learn more about how to accomplish this without any group buys. It wasn't obvious to me how to do it. I sort of stumbled my way to getting something that felt like it could at least be right, but I think there's a lot of better prior art that I'm not aware of.
Yeah, Angela?
This is great, Josh. I can understand how hard this is to do for sure. One of the gotchas you kind of run into just in general, and I have to study this to really truly understand like what you did, but I think one of the gotchas that you run into a lot of times with SQL is depending on the target, they can be a little bid very opinionated in terms of like how SQL should be, what kinds of things you can do. CTEs, for example, not every dialect's going to understand. And then, there's optimizations that can be done after this that you can rewrite and things like that. And one of the things I think I found, as we went through our cycle of building our own SQL generator from our AST is when we discovered Calcite, Apache Calcite. It was super interesting because they have all kinds of support for building their own optimizers and pluggable optimizer architecture, and like comes with Volcano and all kinds of really cool stuff. And I'm wondering, could something like this maybe fit in with something like Calcite, so we can kind of take it at the AST level and then go last half mile with something like Calcite, where you could say, and I know it's another Java dependency or something else, but it might be interesting to say, if once we get an AST, we have a couple choices with Calcite. We can take it directly to their SQL AST or something like that, and you get a lot of bang for your buck at that point.
Yeah, I think that's really interesting. And particularly, I think those kinds of tools might be, if we ever want to get past writing view definitions as JSON and have some more idiomatic SQL syntax for them, we've sort of put that off to after our first milestone, and rightly so, I think. But that is a place that we will land if we are successful with our first milestone. So we want to be thinking ahead too.
Yeah, these are great topics, and boy, yeah, it's like it makes you think. We definitely have a plenty of content for the Dev Days sessions. Yeah, Josh, I love that walkthrough and touching on that, and there's so much we can explore. Like, I mean, I love to participate in a hands-on. Like, we did some exploration as well. I mean, the approach that I had taken to kind of summarize, like we were able to avoid the group buys, but it was taking advantage of SQL engine specific capabilities. So basically, like, because fundamentally a FHIR path expression, it's just like a recursive structure, and you can nest SQL recursively. So we basically would have like tons and tons of, several nested layers of like inner selects all the way down. And it just so happens that the SQL engine that we were targeting for that worked quite well. I mean, kept everything local, so you didn't have to do any sort of like joins between tables and everything. So we didn't actually really use CTEs at all. We just kind of had this deep tree of nested selects, which made the SQL look almost entirely unreadable by a human being, but it worked entirely efficiently. So I think there's a bunch that could be explored there. And I think maybe similarly, to the point that's brought up of a common representation of some sort of intermediary representation, I think is huge. I think that every project is going to naturally emerge on some sort of intermediate representation. Maybe if we can find some sort of commonality for that, then we might get a chance to plug into more engines there. So yeah, fun stuff.
Looks like I'm next. So thank you, Josh. Good try. So I would give you a hint. So if you would like, I can show how we did this. So, but the general shape, it's exactly like this. So you having IST, and you're doing transformation of IST into SQL IST, and then generate the query. Yes, but the general shape of the request, it should be like a series of lateral joins with the subselects, not common table expressions, but lateral joins, and most of database engine do support it. And that's, I think, the general recommendation for like SQL on FHIR to view definition to SQL. Because otherwise, if let's say if we're going to talk about Postgres, if you use common table expression, they are eager, and you will definitely have a lot of performance problems if you like you did. So it just doesn't work on a real scale. Yes, but the lateral joins, the database quite smart. They doing these lateral joins per row, so it really looks like they iterating the rows, yes, and doing this temporal expand and joins calculate stuff and go. This will work. And I think the most of guys do it through the lateral joins, series of lateral joins. Okay, and if you're interested, I can quickly go through like samples what we have inside, and then your turn.
So on that point, I could share my screen real quickly. I put Josh's example, which is a neat example. I probably missed something because I was trying to do it while still watching, into the like very broken proof of concept I wrote 2 connectathons ago, maybe. And I think it does something closer to what Nikolai is saying, where it creates kind of a giant table and then filters that. It may not have, I'm curious, I have to actually think about your implementation, Josh, and this implementation, and whether there's a gap in terms of correct behavior here, because I was going more for what's the most correct code I can write. And also, of course, this is the old syntax because I haven't updated this and it's broken in several ways. But when I drop it in, I basically get a couple unnest lateral joins and then some where clauses for the A1 and A2. Is this big enough? I can also make it bigger. So I guess one thing I want to look at maybe after this call, or if people are faster than I am or have had more sleep than I am recently, whether this would return the same result. But it does kind of work, and it generates this SQL with kind of 3 lateral join and nests here. And this is all live. So if you go to FHIR.vercel.app, you can play with it, but you have to remember our old view definition syntax, which is like the hardest part of writing this stuff. But it's all kind of generating this on the fly. So I guess I'm curious, I don't know from a performance perspective if this is better or worse.
This is definitely
the engine.
optimal query.
Yeah, so it's doing this live. So you could change this. It has, I think, most of the functions, none of the union all stuff, and there's some bugs around ands and ors inside of where expressions and exist expressions, but it does most of it. So at some point I want to pick this up and kind of update it to the latest version since it's pretty out of date. Yeah, this is another kind of a different SQL syntax that kind of focuses more on trying to be as flat as possible. The one point where I have to go into subqueries is with first. So if you had like name.first .where, then it joins into a subselect to be able to do a limit 1, unless it's in the select itself, in which case it uses like the DuckDB syntax given like if we did given first here, it would then just do a path expression instead of creating the subselect. So it tries to figure out if you're doing subsequent selects within the within the field, or if it's returning that. And I think it supports name too. So maybe, let's see, did we call it name back then? I think maybe it was alias. Oh no, it was name. Okay. So yeah, so it has some of the SQL syntax, but anyway, this is just a different approach to generating the SQL. I would be interested to know if there's. Yeah, sorry.
Sorry, I was just going to ask, is it possible with any of these to actually leave it as a collection, so not explode it, have it as an array in the result?
It'll do that so this is just generating, the version the prototype is just generating SQL. So it will generate SQL that that returns kind of whatever structure is at that point that you leave it. So if you did just name as your field, it would return the full name structure. It's designed for DuckDB, which kind of natively supports that in the response.
Yeah, and a similar thing for the example I showed with SQLite.
Mm-hmm. Yeah, if you're interested, I can show some examples from our codebase. Yeah,
of course.
And Dan, this was very cool. Can you put the URL on the chat if it's accessible?
Yeah. I do have to warn you though. I wrote it over one connectathon, and it's extremely broken at this point.
Sure.
So and it uses the old syntax from like a year ago. But with all the caveats, it's public. It's on the web. I'll just go to it.
Yes. So first of all, we are using like advanced feature of the Postgres, which is called JSON path. So in some part of work is done from translating FHIR path to JSON path. So you see how it can be translated. So some examples, so that they quite close to each other. And this little bit much more simpler than just doing lateral join on every stuff. So some path expressions can be expressed as a JSON path stuff. Internally, yes, this is done through some IST representation of the JSON path, and the engine by themselves is just a translator, which translate FHIR pass to JSON pass. And then we can even jump, I think, to the implementation like here for each, let's say, some example. Yeah, you see these functions are returning the IST, which do like Postgres join, lateral true, and put some additional expressions and then generate the rest. And if we jump to the tests, so it will look like this. So for example, here we have columns and we have, what we have else? So we have select with the columns and it's old syntax, yeah, so it's like for each. But the general shape, yeah, here if we just getting specific fields, we even can put JSON pass expressions into the select part, and for each and stuff we use explicit lateral join with some criteria. Yeah, here some criteria are quite stupid, like on true. So, but potentially the where could be here, so we can even filter by the where. Yeah. So, and we have a demo in 8box. We're gonna make a public demo, and these queries are available. So when you are running view definition in 8box, you can see what are queries generated. So there are some tricky parts because there are a few JSON pass functions like query array, query first. They have slightly different behavior, and you should choose the right one. And yeah, John, your question. So this query first will handle most of situation like taking a specific type, but there probably can be some problems with arrays. And some of these functions do like implicit, so that may be a little bit tricky if you're getting array as a result. Yeah. Questions? Yeah, I'm done.
I was going to pipe up before, but I was questioning my ability to explain it. But previously, our implementation, we used a sort of eager nesting is the way I would explain it. And we used joins to implement different syntax structures in FHIR. So we used a combination of it. In Spark, it's called explode and joins to achieve the logic within functions. But recently, we've refactored the whole implementation to be a lot more performant, and we've basically removed all joins because we've figured out that joins are basically poison in Sparkland. So now what we have is the only time we really ever use explode is kind of at the tail end when the user asks for it. So they have asked for each, so we explode at the end. And the way that we do the rest is that we have particularly a collection representation and expressions on top of that in the select clause. So we build up a complicated select clause expression with functions that operate on collections largely, which moves all of that sort of computation into that select clause. And then the only time we use sort of a join or a lateral view join is if the user actually wants there to be more than one row for a resource. And we found that was actually a lot more performant in Spark because it precludes a lot of the necessity to move data around, because every time you want to join something, you potentially have to distribute data around between the different workers, the different processes that are operating on the query. So that was just one of our findings.
I'm still curious how you can do like for each without lateral join. If you put in select like it's probably implicit lateral join, but I don't know how you can do for each without lateral join. If your collection is exploded, yeah. Let's say you should iterate through the names and you want to generate row per name. So how you can do this without lateral join?
I think we use the dot operator.
Is the dot operator, and I still don't understand. So let's say the one row should explode into like 3 rows if a question has 3 names. Yes, how it works. I know that in Postgres sometimes like expression and select do like implicit lateral join. So if you put unnest in the select, yes, it will do like implicit lateral join. But I cannot understand how.
Yeah, this is all still pretty fresh, and I'm quite worried about getting this wrong. But I believe what we do is we take that collection of name structs and we turn it into it, and we transform it into collections along the way, and then at the end we optionally unnest it into rows. So we maintain a collection representation as far along the process as we can to get away from that sort of really complicated business of unnesting and then potentially aggregating again, depending on what you want to do. So we kind of try and keep it as a collection.
If you don't mind, I jump in.
Yeah.
Things are piling up on my side. So there are three things. I guess what Josh mentioned, John mentioned, I am guessing without looking at the implementation. Let's say you have two selects and then each of them have like a for each. So basically you end up with a Cartesian product of the two.
Yeah.
So I think what he's saying is that you can keep like one collection for the first one and another collection for the second one, and don't do the Cartesian. And you just continue working with the collections until the very end, which, as you said, you have to produce multiple rows. And at that point, you just do everything that is needed. So I think that, and that's actually, in my opinion, it seems like a neat idea. What I was actually wondering, asking John, are you saying that, even those are slow? Because those shouldn't incur like a shuffle because it's just local.
Well,
everything is local.
It more goes to overall complexity of the query plan, because once you explode, then you've got two different representations potentially. So then a subsequent operation on already exploded rows, you need to somehow deal with that. So it just makes it end up in there being more steps in the query if you explode too early, I think. But we did have to do one bit of semi-custom function to do the union stuff. So we actually had to create like a cross-product sort of SQL function to implement the union part that we wrote using the Catalyst API, so that can again still follow our pattern of doing pretty much everything in the select clause. But other than that, it all works with the basic functionality.
Cool,
and it's a lot faster.
Sorry, two more questions and I'll shut up. I talked too much today. So easy one for Nikolai, is your implementation open source? And if it is,
no, our implementation is not open source. Yeah.
Okay. And then for John, so just trying to understand what you're saying. So these functions that you mentioned you use are these like user-defined functions, like custom functions, or are there like these user-defined functions that are injected into your SQL?
It's
and by the way, I think it's with sorry, go ahead.
Yeah, for the part that we're talking about, it's mostly Spark SQL. Of course, we have user-defined functions in there as well for doing all sorts of things, like we use user-defined functions to implement some of the functionality and also terminology stuff. But most of this stuff that we've been talking and demoing is possible just using array collection functions in Spark. So yeah, Bashir, we're probably like overdue for a session outside of this meeting as well to just get into the details.
We want to know details as well. So John, if you can do with us, so I would love to join.
Well, our implementation is open source. Feel free to have a look, and I'll do my terrible job of trying to explain it all. But yeah, happy to sort of go through like that demo that I did. I could go through that in more detail and sort of go through the plan. I left out like the query plans out of that because it's just a bit too much and a bit too technical, and we only had 10 minutes, but we could certainly do that.
Yeah, thank you.
Yeah, a question from the examples that you showed, Nikolai. You may have already showed this and I just missed it. For cases where you have nested select view definition, do those sometimes turn into nested selects in your queries?
I don't think we have a nested select. So each nested select will do additional lateral join. Yeah. So they linear. They're not nested. So every level just add the new join.
Got it.
Sometimes this kind of lateral join may be for the huge SQL expression, yes, but it's still like a linear list of lateral joins.
Yeah, and those are optimized in a way that keeps things local.
Yeah, but that's usually, I think the Spark doing the same stuff. So that most of databases, they do this lateral join locally, and it's a different thing than common table expression. So it behaves differently.
Cool.
And it should be quite optimized. And I have a question and the idea for guys from Spark, because as I understand, you can extend Spark with a Java code, yes? And I'm still curious why not just implement the FHIR engine for Spark, maybe more efficient than like the original one, but then you can just run like original FHIR pass in Spark, which can simplify things a lot. Yeah, I've tried to do this the same for Postgres and C, but that's real change. Yeah, but for Spark and Java, I think it's well. Did you think about this?
So do you mean like so the other FirePath engines, the way that they work is that you run it on a resource and it gets a result for a resource. So what you're talking about is running a FirePath engine like that over each resource, getting the result, and then sticking that in a table or something.
Yeah, I mean something similar to what we're doing in Postgres, having JSON pass, so you can contribute direct FHIR pass function into Spark, and then when it's convenient, you may write this function. It produces probably row set. I don't know how it's called in Spark, but yeah, like set, yeah, the collection of rows. But potentially it's pluggable, yes, and it's quite easy to implement, and it can be done very efficient.
Well, I think part of it is, a lot of the work gets done in encoding. So we go from JSON to sort of this structured form in a Spark data set or Parquet, which is already sort of pulled out into arrays and structures and all that sort of stuff. And then the part that we build from the FirePath is the query on top of that, which is just pulling it out of that structure. So it's doing only part of the work. If you wanted to go all the way from sort of JSON through FirePath to a result, you would almost have to do that whole job every time, I think. That's kind of my reaction to that. But yeah, it's an interesting idea. I have no idea what the performance characteristics would be.
So I guess there are two, when you want to use a Spark on, let's say, on a larger scale, let's say Fire data or whatever, so you can have two approaches. One is that you can, like you said, you can every time, and like John was saying, every time I apply, let's say, my FirePath or whatever it is on each of the resources. So basically, the benefit that I get from a Spark is the distribution, like, the horizontal scalability. Mm-hmm. And then I just add enough more workers to actually do this as fast as I want. But every time, like John said, I read the resource, like let's say JSON resource or whatever, I apply the FirePath equivalent of it, and then I just produce what I need. And then there might be some logic to actually combine this. Another approach, which I believe like Pathlink and John is using, and we also rely on a similar idea, is that you do a transformation first, let's say to Parquet, and then that completely changes everything, right? Because it's like a columnar format. The columns are actually compressed and all of that, right? Then that, that kind of mindset doesn't work anymore, that, you have like single resources and then you apply the FirePath and then you do it. Instead, we just, the idea that John was describing is to convert that into SQL, like a Spark SQL, and then rely on the query engine of the Spark to run this on Parquet. Now, I just want to add this one caveat that what I showed in my demo, like a few weeks, I guess 2 weeks ago in Connectathon, the way that we do it inside our pipeline, which does the Parquet generation as well, we have moved the SQL on FHIR v2 implementation into that pipeline. So it's it's closer to that first paradigm that, you have resources and then you just directly create like views out of them. But that's when we want to generate views for, let's say, Postgres or any other relational database. Mm-hmm. If we want to use Parquet and Spark, we still rely on the other paradigm, which is, creating like a columnar format out of it, and then relying on a Spark SQL to do the query.
Well, I
hope that, I didn't confuse people more.
Even in the first paradigm, when you like having the whole resource in the Parquet, you may leverage the FirePath engine in Spark. This can dramatically simplify the SQL you are generating for Spark to run, and probably this can speed up the stuff. So instead
doesn't that FirePath engine rely on having the whole resource and then it operates on top of it?
I think you can write like FirePath engine which can work on top of Parquet without relying on having the whole resource. So that's my idea. So I wrote a few implementations, and I don't see why it's impossible. So you can really implement it on top of Parquet. You can make it very efficient, like the same efficiency as a Spark has for accessing attributes, like separate elements. And but it can be a little bit smarter, yes. And then your queries can be much more simpler. So that, I mean that you can simplify the SQL as we do in Postgres. Yeah, we still have to translate from FHIR path to JSON path. They're not the same languages, yes. But if that could be the same language, so then things will getting much simpler. And from my point, yeah.
I think that is essentially what we have done. I mean, not the standard representation intermediate, but yeah, I think in some ways our at least our new refactored implementation is kind of similar to your JSON path implementation in that we're building it on top of the Spark data frame, which is an important distinction because that's an abstraction that buys us a lot as well. You know, like we don't ever need to go through Parquet. We can keep it all in memory. We can use arbitrary other sort of, you know, we can plug in other sort of actual persistence formats and we can also persist it in lots of different ways on the other side once we've I think essentially what is an evolution of the schema that Ryan came up with when he originally did the SQL and FHIR v1 and Bunsen and all that.
Mm-hmm. Yeah, so then our implementation much more similar than it could look at the first glance. Yeah.
Yes. Yeah.
Okay, so we are in time.
Yeah, we're just running up against time, but no, this is a really fascinating conversation. As we were talking, I was thinking like, I'd love to think about potentially next steps. We think that potentially there are more discussion. Obviously, there's more discussion items that we'd love to go into from this, but just throwing it out to the group, where do we want to head next in this?
I would just suggest, do we have like a dev days submission for just view definition to SQL? It seems very interesting, and there are different approaches different teams are doing. Seems very, I mean, it would be nice to have one full session in dev days for that.
In my list, we don't, because we already have about 4. I think we could, let me put up a list of the ones that we do have. And obviously we only have one more day before the deadline. But yeah, I agree. I think this is an interesting area. But that's one action item, at least to consider. Any others from the group?
Yeah, John promised to show how puzzling is implemented. I would love to see, and maybe Bashir can show what they did. Yes, so we can like have a Spark session.
SQL and Spark, yeah.
I think FHIR on Spark.
Spark on FHIR. Spark of FHIR. I don't know if it makes sense for that to be a dev day session, but let me put that on the docket for a session during this meeting. Does that sound good to everybody?
Yep.
Okay. Great. Will do. Well, thanks everybody. Yeah, super interesting discussion today. So thanks again.